Awesome. So we're going to talk about U substitution.
What?
U substitution. Okay. So U substitution is a way to integrate things that are more complicated, that you might think that you're not able to integrate, but spoilers, you really are able to integrate them. So, I know. We're going to go over this over 2 days. So today we're going to have a worksheet doing U substitution, and then tomorrow we're going to look at a book assignment that's a bit more complicated. Gentlemen?
Hey.
So today we're going to look over relatively simple cases of U substitution. Tomorrow we're going to go over a little more complex cases. So let's start out with, so I'm going to do an indefinite integral here. So if I don't put numbers top and bottom, that means you're just finding the antiderivative, and your answers need to have plus c at the back. If I put numbers top and bottom, then you're actually evaluating them with those numbers, and you don't have to have the plus c. So no numbers top and bottom, you're just finding the antiderivative, and you have to have plus c at the back. So let's do, let's see if I actually can do this. So let's do 6x squared, and then in parentheses, we're going to do 2x to the third plus 1 in parentheses dx. So we're going to try to integrate this bad person, girl, boy, thing.
Oh. Is this recorded?
Yeah.
Yay.
Yeah.
Did someone do a cool intro?
No.
No. So about the intro, I was thinking, if you guys were to come up with, say, 10 Panther Bucks, I would make an intro.
I've got 5.
Okay, hey,
I've got 8.
let me finish. 10 Panther Bucks will make an intro. 20 Panther Bucks, I'll let you script an intro and I'll still make it. 50 Panther Bucks, I'll let you make the intro. Has to be appropriate. Just saying.
I mean, it's not like we couldn't make it into it and like we started it when we started talking.
Right. No, but I'm saying like an actual like animated one with like
Oh my
like
God.
like a real one.
Oh.
Like not just me. Well, it wouldn't be unique to everyone, but I'd have like a brand one where it'd be like
Yeah, no. You could be
But
like
you
one
put
for
out
every
all
single-
yeah, like a bumper.
Yeah.
Yeah.
No way.
Yeah.
That's so cool.
So
What the 10 one?
so 10 Panther Bucks and I'll make one. 20 Panther Bucks and I'll make one that you write for me. Has to be appropriate, nothing inappropriate. 50 Panther Bucks, I'll let you make one for me.
If I had some guys, I would
Okay.
confused. I got 30, but I got none. What?
We just start like a collection jar. And like,
Yeah.
You want to make it yourself?
I don't have a due date on this.
oh, sick.
I'm so excited.
We got all
I'm
cute.
going on.
I got five.
I don't have a due date on this.
5 and 5 is 10.
Dude, guys,
I don't have a due date on this.
I get mine out.
Okay, so just throwing that out there.
Oh my God. So we're already at 20 pretty much.
Just throwing it out there.
I'm glad we're at 20.
Okay, so let's get back to math here.
You didn't think about that this weekend?
Yeah.
So stoked.
So let's get back to this. So this, because there's no, like, because we got the stuff that's inside the parentheses, this is a little bit messier to integrate. So U substitution is a way to integrate this, because what this really is it's a composition of 2 different functions. So here's how we do it. So step number 1, you pick an inside part to be the U. To be the U. Usually it's going to be the messiest part. In this case, the inside part is what's inside the parentheses here. So our U in this case is going to be 2x to the third plus 1. And that's step number 1. Step number 2, we're going to find the derivative of U. Find the derivative of U. And so U prime is equal to what?
1/2 x to the 4th plus x. Oh, no, that's it.
Yeah, it's antiderivative. Shift gears. There we go. Nope, you're still you're half and half now.
6x squared.
6x squared. Now, because we're doing this with this whole u thing, I have to throw on dx. Because we're doing this whole u and x thing, I have to throw on dx. And the dx actually helps you out. I know that you guys hate seeing that extra dx part, but it actually helps you out, believe it or not. This dx part right here, I'm going to underline it. I'm even going to point to it. I'm going to say, important, don't forget. Important, don't forget. All right. Now, I'm going to substitute things in. So I'm going to substitute, step number 3, sub stuff in. Sub in. So I'm going to substitute u in for 2x cubed plus 1. So instead of being 2x cubed plus 1, this is u. And I'm going to move this 6x squared kind of to the back here next to where the dx was. Because 6x squared dx, hey, guess what that's the same as?
No way.
And so I'm just going to replace that with, so this is u, and instead of using u prime, I'm going to use du. I know you hate it. That's how I'm going to do it, though. And the reason I'm doing that is because now I have these this way. So I'm just doing the integral of u du. Okay. So now I'm going to integrate u, just plain u. So I'm going to kick u back. So if this were u, instead of using x, if I'm using u, if I'm integrating that, like finding the antiderivative of it, what would be the antiderivative of u? So now you're switching gears again from derivative to antiderivative. What would be the u squared over 2? So this would be u squared over 2, and then I got to add the plus c. So step number 4 is,
Where is that?
oh, where'd it go? I don't know.
What happened?
Is it on your computer?
No.
Is it on your paper?
Yeah?